This is a video about angle relationships. By now you should be able to measure angles and classify angles. Classifying angles like obtuse, acute, right angles, and straight angles. Now we will identify and use special pairs of angles and identify perpendicular lines. The special pairs of angles we're going to look at are adjacent angles, linear pairs, vertical angles, complementary angles, supplementary angles, and angles formed by perpendicular lines. The first vocabulary word is adjacent angles. Adjacent angles are two angles that lie in the same plane and have a common vertex and a common side, but no common interior points. So let me explain what that means. We have angle 1, and it's right here. And we also have angle 2 right here. They lie in the same plane. They have a common vertex, okay, and a common side, but no interior points. So what that means is all the points on the interior of angle 1 are different than all the points in the interior of angle 2. So we do have adjacent angles here. Here's another example. Angle 1 is right here, and angle 2 is right here. They do have a common vertex and a common side. But the interior points of angle 2 and angle 1 are all different. They do not have any common ones. They don't have any in common. These next examples are non-examples, okay? So angle 3 and angle ABC are non-adjacent angles. So angle 3 is right here. And angle ABC is this big angle here. So they do have a common vertex and a common side. However, all of the points in angle 3 are also inside of angle ABC. So they do have common interior points, and therefore this one is not an example of adjacent. Here, this next one, angle 3 and angle ABC, they don't even have a common vertex, so we can stop right there. But they do have a side that's on the same line, and their angles, interior points are all separate. But the big thing is that they do not have a common vertex. So this is also not an example of adjacent angles. The next word I need you to know is linear pair. A linear pair is a pair of angles, that's two angles, adjacent angles, with the non-common sides that are opposite rays. So what I'm talking about here is I have a pair, angle 1 and angle 2 are a linear pair. Angle 1 and angle 2 are adjacent. They do have a common vertex and a common side. And then their non-common sides are opposite rays, which means they go opposite ways on the same line. Okay, so they have to be making a straight line. And then, so in other words, linear line, pair, two angles, 1, 2. Okay, so this is a linear pair. This is a non-example. Okay, so I have angle ADB. So I trace A to D to B. So this angle right here. And angle ADC, ADC. They are adjacent angles because they have a common vertex and a common side. But their non-common sides do not make a straight line. See how it would normally go straight like this, okay? So this is a non-example of a linear pair. So anytime you see a line, you know that all the angles on one side of it all add up to 180. And so when you divide it into two, you have two angles, so that would make a pair of angles. But notice that they add up to 180 all the time. The next angle relationship that we're going to talk about are vertical angles. Okay, this is also a pair of angles. So vertical angles are two non-adjacent angles formed by two intersecting lines. So we have angle 1 and angle 2 are a pair of vertical angles. Angle 1 and angle 2 are not adjacent, but they are formed when these two lines cross. Angles 3 and 4 are also vertical angles because they are non-adjacent and they are formed when two lines cross. This is another non-example. First thing, you have to have two lines crossing, not one and then it going off a separate way. Okay, it has to be going straight. So we know we don't have vertical angles there. One of the theorems that we have in geometry is that vertical angles are congruent. We have to prove our theorems, but right now I'm just going to tell you about it and your teacher will go over the proof of it. So angles ABC and angle DBE, this angle here and this angle here, they're always going to be congruent. So remember, congruent means same size, same shape. And in angles, all angles have the same shape. It's just a matter of their size. And so they have the same angle measures. And angles ABD and angles CBE also are the same size. The next two angle pairs are complementary angles and supplementary angles. Complementary angles are two angles with measures that have a sum of 90 degrees. It's always two angles, okay? So when you have a right angle divided into two angles, you know that these two angles are going to add up to 90 degrees, and therefore they are complementary angles. Angle 1 and angle 2 are complementary angles. We also know that with complementary angles, they do not have to be connected like the 1 and 2 are. It can be separate angles as long as the angle measures add up to 90, then they're complementary. Supplementary angles, on the other hand, are two angles, again, two angles with measures that have a sum of 180. So angles 3 and 4 are supplementary. Notice this is a linear pair. All of the angles on one side of a line are going to add up to 180. So just by looking at this, we know that angles 3 and 4 are supplementary. We can also have two angles that are not touching, as long as they don't have to be adjacent angles, as long as the sums of their angles add up to 180 degrees. That makes them supplementary. And finally, we have perpendicular. Perpendicular lines intersect and form four right angles. So I have one angle marked here with the box, but since opposite it, the vertical angles are going to be congruent, and next to it, 90 and 90 have to add up to 180, so this is a linear pair. They have to be congruent, and these vertical angles have to be congruent. So perpendicular lines intersect to form four right angles. Perpendicular lines intersect to form congruent adjacent angles. So remember, congruent means equal measures, and adjacent means right next to. So these two angles right here are congruent and adjacent. Segments in rays can be perpendicular to lines or other line segments in rays. So it doesn't have to be lines. You can have segments that are perpendicular. And we know they're perpendicular if they form four right angles. The right angle symbol in the figure indicates that the lines are perpendicular. So the symbol upside down T here is red is perpendicular to. So for example, we have line AD is perpendicular to line CB. So keep these symbols handy because it keeps us from having to write the word perpendicular over and over. So as a quick recap of what we've done, we've talked about adjacent angles. This is two angles that have a common endpoint, a common side, and no common interior points. So angle 1 and angle 2 are adjacent angles. The linear pair is when we have a straight line with a ray coming from the straight angle, and we have two angles that add up to 180. They are on one side of the line, so that would be a linear pair. Vertical angles are formed when two lines cross, and they are a pair of non-adjacent angles. Complementary angles, when you have a right angle that's divided into two angles, we know that the two angles are going to be adding up to 90. This is two angles that add to 90. So if I had a 30 and a 60 degree angle, those two angles add up to 90. Supplementary angles, one example of that is the linear pair, where we have two angles that add up to 180, or if you just have two angle measures that end up being 180, like 50 and 130. And perpendicular is when two lines cross, they form four right angles. We also have congruent adjacent angles. This symbol is what we use to show that those lines are perpendicular. And the symbol for perpendicular is this symbol right here.